in this video. Hello everyone and welcome to my 9th video on the channel, and oh my god, we are so close to the 10th video on this channel, and it's going to be another amazing lesson. Of course, the 10th video, the 9th video, it's all going to be like that, but I can't believe it, time is flying by. The 9th video on this channel, oh my god, it's amazing. And of course, one more favor before we get on to our answers to our previous questions. Of course, please make sure to hit that like button and smash that subscribe button for more awesome content just like this. So without further ado, let's move on to our answers to our previous question. Number 1. Y is equal to negative 2x by 3 plus 5 by 3. Number 2. Y is equal to 3x plus 7. And of course, number 3. Y is equal to 2x. These are the answers to our 3 questions from our last video. Hint, hint, you should watch it. And without further ado, let's get on to the lesson. This lesson is about graphing quadratic functions. Now, a function is, of course, where we have y on one side and x powers or anything. Like I would have x cubed, or maybe maybe 16x, or actually 16x cubed plus pi x plus blah, 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 blah. But the only variable there is x, and on the other side it's y, and that would be a function in our definition. And of course, quadratic functions is where the highest power, and let me review that. Power is where I have like x to the first, second, that's the second power, x to the third. The highest power is the square power, or number 2, so I'd have x to the power of 2, or x squared. That's how a quadratic function is. And this lesson is going to be about graphing them. How you do that is first you got to fill out a table. I'm like, okay, if x is equal to 0, y is equal to what? X is equal to 1, 2, maybe throw in a couple negatives, -1, -2, and that's basically how it works. Of course, then you plot the points, and then you will connect the line. That's how it would work. And just a hint, a parabola, or the kind of graph that you're going to get when you graph a quadratic equations, is kind of like a U-shape, kind of like that. It's like this. If I have a graph like this, it would maybe be like this. And of course, everything's going to be much more clear in the examples, which I'm going to show you shortly. So without further ado, let's get into our examples. Our 3 examples for today are going to be graph x squared is equal to y is equal to x squared plus 2, and y is equal to 2x squared. Let's start with the first equation. Graph x squared is equal to y. What we got to do here is first, of course, we got to do our coordinate plane. So if we draw it like this, we're going to get maybe 1, 2, 3, 4, 5, 6. I'm just going to make the smaller 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's make it 10. -1, -2, -3, -4, -5, -6, -7, -8, -9. It's getting confusing. And -10. I know this looks a little confusing, but actually, for this problem at least, you won't have to worry about this. And I'll show you why in a minute. But we have here -1, -2, -3, -4, -5, and -6. So, how do we graph this? As we do, first, let's create a table. What we're going to do with the table is it's going to be like this. And we're going to split it up. This would be our split. I know it looks a little ugly, but trust me, it'll get the job done. X and y. If x is equal to 0, 0 squared is 0. If x is equal to 1, y is 1. And if x is equal to -1, y is also 1, because -1 squared is also equal to 1. If y is 2, if x is 2, y is 4. And of course, if x is negative 2, y is also equal to 4. Let me just write that here. So with our table done, let's start graphing. We have x is equal to 0, 0, 1, 1, and 2, 4. Negative 1, 1, and 2, 4. So, but how the points would actually go, we would also go to 3, 9, and negative 3, 9 if we substituted it. But I just didn't want to waste your time by just doing a ton of points, so all I wanted to do was just give you the basic idea on how a table works. And always, you actually don't really need the table, because if you know it well by memory, like I could be like, okay, if I have x squared 0, 0, 1, 1, negative 1, 1, you don't actually need a table if you can quickly calculate in your head. And of course, the problems I'll be giving you aren't too complicated. And if there's going to be a complicated problem, you're probably going to use a graphing calculator anyway. So trust me, if you learned it by memory, it can also save you some time. And if we connect the lines over here, what we get is, oh my god, it's above the x-axis. Because remember, no value of x squared can be negative. So and no, that's not intentionally why I did it messy. That was completely accidental, but it's not very important to worry about this. But you should probably just label it just for sufficiency and just to practice labeling. As always, practice makes a person perfect. For our second example, we're doing y is equal to x squared plus 2. And this is actually a little bit different because we don't just have x squared. We have x squared plus something. And in this case, it's x squared plus 2. What we got to do in this situation is, of course, we got to draw the quadratic plane. Not quadratic, sorry. Coordinate plane. Let's start like this. And actually, let's make the y ones a little bit longer so it can fit all the numbers. Like 1, 2, 3, 4, 5, 6, 7. Let's just put it up to 7. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and let's go all the way down here, negative 7. So this would be our coordinate plane. And of course, we would have to do the table. Or if we wanted to do the table, we could do the table. I'm going to show you a table in this example, but in my next example, y is equal to 2x squared, I'm going to do it without a table to show you how it would look like. But for now, as I said, let's do a table in this example. We got to start with, of course, 0, 0 in the basic frame. Let's add a couple more values because, honestly, let's be honest, that last table was way too small. If we have 0, actually we're going to have 2 because 0 squared plus 2 is 2. If x is equal to 1, y is equal to 3 because 1 squared is 1 and 1 plus 2 is 3. If x is equal to 2, y would be equal to 6 because 2 squared is 4 and plus 2 is 6. Of course, negative 1 would be 3 also, and negative 2 would also be 6. All right, I just realized 1, 2. Gotta mark the rest of this coordinate plane because really, we can't really work without an unmarked coordinate plane unless you're doing a rough sketch of a graph, which is kind of rare until like higher mathematics. So we're not going to cover that here. This is Algebra 1. Let's keep it simple. 0, 2, 1, 3, and 2, 6, and so on. Negative 1, 3, negative 2, 6, and so on. So if we draw the line, it would look something like this. And as you can see, it's actually quite interesting. Because if we have the graph of x squared, at any point, it's always 2 units below. And that's where the plus 2 comes in. So if I add plus 2, it will bring the graph 2 units up. And that's just some sort of visual representation for you to think about. Maybe add your interpretation in the comments. Any questions, tips, or thanks, of course, they're all available. And that's our second example. Now, for our final example, which I'm actually just going to pull up in a minute, if we want to graph y is equal to 2x squared, what we got to do is, of course, start with the coordinate plane. 1, 2, 3, 4, 5, 6, 7. And actually, let's move this a little bit because I actually want to make room for 8. Trust me, you'll see why in like a minute. Not a minute, sorry, less than a minute. Don't worry. I'm not going to use that long to just graph a simple function. Negative 1, negative 2, negative 3 all the way. And of course, let's add that 8. So I'll just inform you when I'm done with this coordinate plane. So if we want to graph this function, we're going to have to start with the table, or not. As I told you in this example, I'm just going to show you regularly how I would actually do it, because I don't actually draw tables that much. That's just to get the stepping stones to be able to do it more fast and by memory. So I would be like, okay, 0 times 2 is 0. So we have 0, comma 0. 1 squared is 1. 1 times 2 is 2. 2 squared is 4. 2 times 4 is 8. And the same thing for -1 and -2. So what our graph would look like right now is this. And look at this. It actually seems like it's more narrow, almost 2 times more narrow. And that's where this comes in. If it's 2 times x squared, it would be two times more narrow. Kind of, not really. But if it was 1 by 2x squared, it would kind of be 2 times wider. So that's really simple, and it's actually kind of fun to say these visual representations, as always. And that's the graph. That's really the examples. And of course, none of our lessons is complete without me assigning you some practice problems, which you can post your answers down in the comments. Actually, no, maybe you can't. Or maybe you can. Who knows? For our first example, for our first practice problem, my bad. We're going to graph y is equal to x squared minus 2. For our second example, we're going to graph y is equal to 3x squared. And for our third example, we're going to graph y is equal to x squared plus 1. And I guess that's going to be it for today. Thank you so much for listening and watching, and see you in the next one. Bye-bye.